The new AI X1 Pro from Minisforum delivers next-gen AI-powered performance. With its XDNA-powered NPU, AI-optimized Radeon GPU, and powerful AI-capable CPU, this compact powerhouse is built to accelerate AI workloads and unlock AI power. I can't. It's too much. It's too much AI. Anyway, this little mini PC from Minisforum features one of AMD's AI CPUs, and it seems pretty impressive. But the real reason I wanted to check this out wasn't the CPU or GPU, it was actually the NPU, which is supposedly a big step up from the previous generation. And that got me thinking, what if you had one of these NPUs in a home server? Imagine it handling object detection for security cameras, facial recognition to organize a photo library, or even running a lightweight large language model, all while using a fraction of the power compared to a CPU or GPU. Could systems like this with a dedicated efficient neural processor play a bigger role in home servers? Well, the short answer is no. At least not yet. But there were some moments where the NPU really shined, and overall this PC was fairly interesting, so let's take a look. NPUs, or neural processing units, aren't new. They've been in mobile devices for years, handling on-device voice recognition, image processing, and other machine learning tasks. Much like how modern CPUs have dedicated video encoding and decoding hardware, NPUs are optimized for efficient parallel computing, matrix math, and, well, other AI stuff. Now, I'll be very clear, I am not an expert when it comes to machine learning stuff at all. In fact, I'm pretty new to this, and so I'm sort of just figuring things out as I go. So take most things I say about machine learning with a grain of salt, and if you're looking for more information, there's fortunately a plethora of people out there who know a lot more than I do. Lately, there's been a flood of marketing around AI-capable processors from AMD and Intel, highlighting how they can be used in everyday applications. Microsoft, for example, is pushing its Copilot Plus suite, which includes real-time caption generation and translation, while DaVinci Resolve has started promoting NPU-powered video editing features. And I get it, the AI buzzwords and hype is so overused, and just researching this video was exhausting. For example, on one of AMD's product pages, I did a Control F for AI, and it showed up more than the words the, an, a, and of combined. That being said, I don't want to completely dismiss what these products might be capable of. There likely are some genuine productivity, workflow, and quality of life benefits to having an NPU, and, well, maybe even benefits to having one in a home server, at least in the future, because right now getting the NPU in this thing to do anything took quite a bit of work. In fact, I found myself spending a lot of time running Python code. And if you've ever tried learning Python or any coding online, you've probably run into the biggest problem, which is boredom. That's why the sponsor of this video, Boot.Dev, is tackling backend development in the smartest way possible, by making sure you actually enjoy the process. Backend development is what makes the internet actually work. It's the code that handles things like databases, APIs, servers, the stuff that actually keeps things running behind the scenes. And Boot.Dev teaches you how to master it from start to finish with hands-on lessons in Python and Go. You won't just read about how these systems work, you'll actually build them. With a mix of theory and real projects, an active Discord community, and gamified learning that keeps you engaged, Boot.Dev helps you stay motivated while actually writing real code. You'll earn XP, level up, complete quests, and even climb a global leaderboard, all while developing the skills to land a job in backend development. And also, this isn't a talking point they gave me, but I love that for such a fun video game like UI, you can use keyboard shortcuts for everything. You don't have to touch the mouse at all. It's a small detail, but it makes the whole experience much smoother. To make sure you're getting your money's worth, every course has a free demo, and there's a 30-day no questions asked refund policy. So if you're ready to start building the backend systems that power the web, while having some fun, head over to Boot.Dev and use my code HardwareHaven to get 25% off your entire first year if you choose the annual plan. Now, before we start really diving into all of the NPU stuff, let's talk about the system the NPU is in, the AI X1 Pro from Minisforum. I decided to take a look at the system mostly for the NPU and AI stuff, but Minisforum also made what is, in my opinion, one of the best mini PCs of all time, the MSO1. Now, this definitely isn't the successor to that, but Minisforum has impressed me in the past, so I wanted to see what they were bringing to the table with this. Now, to be clear and transparent, Minisforum did send this over for me to take a look at, but as with any time a brand sends me a product for review, I didn't get paid, no money exchanged hands, and they don't get to tell me what to say or even see this video until you do. The AI X1 Pro, or just the X1 Pro as I'll refer to it moving forward, isn't the tiniest mini PC on the market. It's very similar in size to the tiny mini micro lineups like I just talked about in my last video, but it also has the benefit of having a built-in power supply. This is really nice as you don't have a clunky power brick to lug around or hide somewhere, but it does mean you have the potential of a proprietary power supply failing after the warranty period, so do with that what you will. The X1 Pro is built inside an aluminum case with a removable plastic bottom, and overall I found it to just be a very pleasant looking machine. On the top, there's a touch sensor which makes signing into Windows a breeze, and on the side you also get an SD card reader. On the front there's a USB 4 port, two 10GB per second USB Type-A ports, a combo audio jack, a built-in microphone, and the power button. Oh, and also a dedicated Copilot button for people that I guess just don't like keyboard shortcuts. On the back, you get another USB 4 port as well as a USB 2.0 port, HDMI and DisplayPort connectors, dual 2.5 gig network interfaces, and you even get an Oculink connector for 4 lanes of PCIe Gen 4, which means if you really wanted to run this beautifully compact setup by doing something like this, you can. Getting the system open is pretty easy. You just remove the 4 screws that conveniently aren't covered up with rubber feet or anything, and then you remove the 5th screw that is covered up by a little rubber pad for some reason. With the bottom cover off, you can actually see that there are 2 blower fans, one for the CPU and another for the power supply. You have to remove quite a few screws to remove the power supply, but fortunately they're all identical. Before pulling it out, you disconnect 3 cables, one for power, one for the built-in speakers, and one for the fan. And you might be wondering why there are only 2 cables here, and that's because off camera I accidentally dropped the power supply off a table and ripped off the connector for the speaker. That is very much my fault and not an issue with the design, and Minisforum, I'm sure your speakers sound great. Sadly, I wouldn't know. With the power supply out, we can see a few things here, like the 3 NVMe sockets. These all support PCIe Gen 4, but later on in testing, I found that the 3rd slot only supports 1 lane of PCIe. I couldn't find that anywhere on their website, even though, well, in an email, Minisforum confirmed my finding. So yeah, Minisforum, you should probably mention that in your specs. Now, one of the awesome features with this system is that rather than LP DDR5, it actually has socketed DDR5 SODIMMs. My model came with 64GB, but you can actually get up to 96GB in this system. Finally, we have the CPU, which is the Ryzen AI 9 HX370. This features 4 of AMD's full performance Zen 5 cores, as well as 8 Zen 5C efficiency-focused cores. It also includes the AMD Radeon 890M integrated graphics, and as we mentioned before, the XDNA-powered NPU, capable of 50 TOPS, or trillions of operations per second. Now, I didn't do a ton of benchmarks on this system, and even if I had, I wouldn't have the data to compare it to from other similar systems, so I'll make sure to link some reviews down in the description that will hopefully provide some more information if you're interested in purchasing one of these. I did run just a few benchmarks like Cinebench R23 for example, and in the multi-threaded test, it only fell short of my editing PC's 16-core 3950X. And yeah, that's an older CPU at this point, but it was still substantially faster than the i9-13900H in the MSO1 I mentioned before. In the single-threaded test, the X1 Pro basically wiped the floor with anything I had in my testing data spreadsheet. And it did that while not drawing that much power. It initially drew 91 watts during the multi-threaded test, but then dropped down to 85 watts after a few seconds. And when sitting idle in Windows, the entire system drew just around 9 watts. Also, the dual fan cooling solution in this thing was impressively quiet, at least to my ears, and managed to keep thermals in check. I also hopped into DaVinci Resolve, and when rendering a 4K timeline, the system took 33 minutes and 30 seconds. That doesn't look great when compared to my editing PC with a 3950X and 7800 XT, which only took a little over 7 minutes. Now, that was using the native software encoding, and I was hoping that switching over to the Radeon hardware encoders would help, but that was actually a little bit slower. So I think it just comes down to the GPU actually being the limitation, so the choice of encoder didn't really make a difference. While rendering was quite a bit slower than my desktop PC, actually editing the 4K timeline was still fairly snappy, so this could still make for a decent editing workstation if you need something really compact. For some home server stuff, I messed around a bit in Proxmox, starting with Jellyfin. And here is where I ran into probably one of my first real issues. Not an issue with the hardware, but just with the software support. I was curious to see how this system might handle hardware acceleration for video because, well, AMD in the past has been pretty lackluster. I was hoping to use Jellyfin just because it's easy to compare that to previous things I've tested, but I couldn't get it working. It seems that the support for these AMD Strix Point GPUs isn't baked into the current release of Jellyfin's version of FFmpeg. It looks as though people are getting it working in development builds, so I imagine there will be an official working release soon, but the lack of software support is a recurring theme, especially when we get to the NPU stuff here in a minute. I didn't do a ton of other home server testing with this thing because, well, you're probably going to have plenty of CPU performance for whatever it is you want to do. But I did run PowerTop Auto-Tune, and I was able to get the idle power draw down to just 7 watts in Proxmox. Unlike the MSO1, this doesn't have any 10 gig networking baked in, but it does have that Oculink port. So I hooked it up to an Oculink to PCIe adapter, plugged in a 10 gig SFP Plus card, and well, I had this really awkward setup, but it does work. So you could pass through a 10 gig NIC or some other PCIe device through to a virtual machine or something. So yeah, overall this thing performs really well. It's very efficient, has some decent I/O, but what about that NPU? Can we start doing some cool home labbing AI stuff? Well, as I mentioned multiple times now, no, not yet. The drivers for the XDNA NPUs won't be included in the Linux kernel until the release of 6.14. And if you go to AMD's documentation for the Ryzen AI software, there's not even a mention of Linux. Everything is currently just running in Windows 11. So there's no telling how long it will be until there's even a possibility that this NPU could be used for, I don't know, accelerating object detection in Frigate, or to handle facial recognition and image, or to self-host an image generator using Stable Diffusion. But there are things it can be used for right now that might just give us a glimpse into the future. I was going to start by just utilizing some of the features that are baked into Windows, like for example the live caption feature. However, when I tried running this, I couldn't get the NPU to do, well, anything. I eventually realized I not only needed to update to the most recent version of Windows, but also manually select the update previews. After that, I was able to actually get the NPU to work for live captions. This not only helped with English content, but I could also translate non-English content in nearly real time while basically using no system resources at all. One application that AMD markets as having support for XDNA is Amuse. Amuse is an app that makes loading and running models for image generation and manipulation fairly easy, and while there was only one Stable Diffusion model available that featured the Ryzen AI variant, I was able to generate some simple images using just the NPU. Now, this was actually running slightly slower than when running the same model off of the GPU, with the GPU managing about 3.5 iterations per second, with the NPU only managing 3.2 iterations per second. But it's important to point out here that the NPU isn't necessarily meant for performance, but efficiency. It was only about 9% slower, but the entire system was drawing almost half the power in the process. Another thing that I was personally excited for were some of the editing features I saw in this video from Snazzy Labs for DaVinci Resolve. However, I couldn't get any of them to work. I think, at least right now, those features only leverage the NPU with the Snapdragon processors running the ARM version of Windows. Now, I probably could have found some more examples of existing software or Windows features that leverage the NPU that just, well, worked, but it was sort of difficult. So instead, I moved on to the documentation AMD has for development within the Ryzen AI platform. Now, there's no way I was going to be developing anything. I haven't done enough Boot.Dev yet, but they have some tutorials and examples to follow. After installing all of the prerequisites, I started following the instructions for a tutorial to run a ResNet model for image recognition. With this, I was able to run the same test on the CPU and NPU, which just identified 10 provided images. It was probably a good example of how to get something running for a developer, but it wasn't a good benchmark. So using my incredible programming skills, I developed a very sophisticated benchmark, and by that, I mean I just made a nested loop to detect those 10 images 1,000 times. And I added a timer. And the results here were interesting. In this specific example, the NPU was really impressive. Not only did it run this process while once again only drawing about half the total system power, it finished in less than a third the time that it took for the CPU. Now, as I mentioned, this was just using a sample of 10 provided images, and I would assume there's probably less accuracy with the NPU, but it still goes to show just how much more efficient these dedicated processors could be for certain workloads like image recognition. Now, once again, if it's not clear by this point, I'm a dummy when it comes to AI stuff, but from everything I've gathered, running a large language model like DeepSeek on an NPU just isn't really practical, as it wouldn't have the performance or the memory bandwidth. While I did see some instances where it seemed like people were able to get some smaller models running on an NPU, the process seemed to be a bit outside the scope of my capabilities. But AMD does provide documentation on how to run LLMs using their hybrid execution mode. This is actually pretty cool because it splits different types of processes out between the GPU and the NPU. Once again, following their documentation, I was able to set up a backend using something called Lemonade, and then connected to that using OpenWebUI. The hybrid execution mode only works with specifically generated models using AMD's Onyx runtime, so I was only able to select from AMD's list of pre-generated models, which are all fairly small. But still, I got a few different LLMs working relatively well. Now you can see that most of the heavy lifting was still being done by the GPU, but the NPU was handling certain processes. Now, interestingly, I noticed that the NPU was being more utilized with certain prompts, like for example when asking a mathematical question. I'm not even going to attempt to try and explain why that is. I'd love to hear some of your thoughts down in the comments, but I did find it interesting. Now, I don't have a good way to compare the performance of running one of these LLMs in the hybrid execution mode or just running it on the GPU, but it is cool to see that there are methods of running LLMs that could leverage the NPU to some extent, and maybe this could make running some of these models a bit less power intensive for home users. It's not very easy to get working though, and unless you're the type of person that can dive into converting and quantizing models to be compatible with the Onyx runtime and Ryzen AI software, like me, you'll be very limited on what models you can use for just about anything. That being said, the system doesn't only have an NPU, and you can run AI tasks like LLMs off of the CPU and GPU. For example, in LM Studio, I was able to run a variety of different models. Since I had the 64 gigs of RAM, I could load in this 70 billion parameter DeepSeek distilled llama model, but on the CPU, I was only getting like 1.9 tokens per second. Now I could leverage the GPU some, but that actually brought the performance down. When only running a 7 billion parameter DeepSeek distilled Quinn model, I was getting a much more usable 15 tokens per second. When it comes to NPUs, while I am interested to see what comes down the road in terms of software support and implementation, there really isn't much use for them right now in a home server environment, or really in any environment except for some specific tasks for productivity or on mobile devices. But as much as I can't stand AI marketing hype, I don't think these NPUs are just a fad or a gimmick. I think it's very possible that we could see these dedicated neural processors put to use in a variety of tasks, especially as the hardware and software develop. But for now, I wouldn't go out and buy something like this expecting the NPU to be a significant value add. That being said, the X1 Pro is still very impressive in many other ways. It's a very powerful, quiet, efficient, and seemingly well-built mini PC. But that comes at a price. My model, with 64 gigs of RAM and a 1TB SSD, retails for $1,230, but at least at the time of filming this, it's on pre-sale for $980. And I don't see it on their website, but when they first sent me the pricing for these, they also mentioned a bare-bones model with no RAM or SSD, and that they had marked for just $880. So maybe they'll launch that in the future, maybe keep an eye out if you're interested. Also, I think I have a code that I'll have down in the description that gets you an additional $50 off. There are definitely cheaper options that probably have a much better value proposition, but if you feel like you need this CPU and a really solid, compact machine, the X1 Pro seems like a pretty good choice. I know this video was a little bit different, but sometimes those are the ones that I have the most fun with, and I hope you guys enjoyed this video as well. If so, maybe consider giving a like, subscribing, or even becoming a raid member for as little as $1 a month. With that, you get early access to ad-free videos, as well as some other perks, so maybe consider checking that out down in the description. That's about it for this one though, so as always, thank you so much for watching, stay curious, and I really can't wait to see you in the next one.